Hi class, today we're going to be looking at measuring populations. This is chapter 19 section 2, and we're also going to go ahead and finish with chapter 19 section 3. In this section we're going to talk about how you can measure a population, counting individuals in a population. So population growth rate is the number that a population size changes over time, and it will depend on birth rate, death rate, emigration, the individuals moving out of the population, and immigration, individuals moving into the population. Now the way we calculate this is we add to a population through birth and immigration, and we subtract from a population by death and emigration rates. So we can assume that immigration and emigration are equal. It's a hard thing to count and to take account for. So a lot of times in calculations of population growth, we will assume immigration and emigration to be equal. That will leave us then with the birth rate and the death rate. So birth rate minus death rate will equal our growth rate for the population. Now, a lot of times, if we go back here just a second, a lot of times this is still difficult to do. And so what we'll do when we calculate a population is we'll take an average or an estimate. So if you're going to count the number of dandelions in a field, instead of taking the huge entire field, you might take a portion of the field, count how many you have in that smaller portion, maybe 1 square mile, and you count them all. Or maybe you go even smaller and you count them all, and then you multiply it by the larger area. So you're taking a small sample and multiplying it by the bigger space that you actually need to know. Now there are a couple problems with that. You could end up overcounting because you have a whole bunch of dandelions in one small area and then not as many that fill the rest of your large area. Or you could undercount. Maybe you don't have very many in that small area that you're counting. And so it really truly is an estimate. It's not going to be an exact thing. Even when we do the census for humans, it's a good estimate for how many people are in a particular community, but it is not an exact number. Now we have two models of growth for a population. The exponential model, which is a J curve, and that's shown here in this first image. And then we have the logistic model, which is called the S curve. So populations will grow in this exponential model first until it reaches a carrying capacity, and then it will slow down. And at that point, it starts to look like the S curve or the logistic model. Populations cannot continue on a J-curve or exponential model forever because they'll hit this point where there's just not enough food or resources, shelter, things like that that's going to allow them to continue to thrive and continue to have increases in population for an extended period of time. So the exponential model is the larger the population gets, the faster it grows. Birth and death rates remain constant. And the limitation that exists will only exist under rare conditions. So it doesn't account for limiting factors that occur in nature, and we'll talk about those in just a minute. The logistic model basically accounts for limiting factors. So a limiting factor is a condition that restricts the growth of a population, and the reason might be food or shelter or water, something that they need in order to survive. The carrying capacity is the number of individuals that the environment can support for an extended period of time. So generally what will happen, the population will grow to the carrying capacity, and then it will fluctuate up and down, above and below this carrying capacity. The population won't really be able to support many more than the carrying capacity because of food and resources that are necessary to survive. So this is our example here. We have the J curve that continues till we get to the carrying capacity, and then we see that at the carrying capacity, the population kind of maintains this general amount in their population. They will go up and down, above and below this line slightly, but overall they kind of maintain that carrying capacity. Here's what it will actually look like. Some things that kind of are reasons that limit a population size: starvation, accidents, pollution, old age, disease, predation, things that will cause individuals to not survive. Now there's two main types of limiting factors. The first is density independent factor, and these are caused by abiotic things, things that are not living. So what will happen is the population will decrease in size by the same proportion no matter what size the original population was. Some examples are floods or extreme temperatures. Those are abiotic factors that cannot be controlled in any other way, and they will affect the entire population no matter how big the population was. If the population was one individual or if the population was 100 individuals, it's still going to affect them all. A density dependent factor are biotic factors. And so in this one, the larger the population is, the larger that the population will be reduced when this biotic factor comes in. So an example is disease or starvation. A great example is a disease. Say the flu comes into a large city like New York. Your chances of getting the flu are very good because you're very close proximity to other people. You're just in a high population area, and so it's going to affect more people. Then if you lived out in the country and the flu came by and your neighbor got the flu, you may or may not get the flu because you don't come in contact with your neighbor all the time. You're not in direct contact with them as you would be if you were living in a city. So biotic factors, these can go through a population very quickly. They can destroy a population very quickly as well. Okay, we're going to go through the last section here is population growth, which is 19.3, and a little history lesson of humans. Humans have gone from a hunter-gatherer lifestyle where there was slow human growth because there was a high death rate to the agricultural revolution where the human population growth increased dramatically because of an increase in the food supply. And then the Industrial Revolution, where there was rapid human population growth because of a decline in death rates. And there were quite a few factors for this. One of the main ones is sanitation. People realize that you can't just have sewer waste going down the middle of the road, and so sanitation was a big key to the reduction of illness. And also advances in medicine. Today's growth, developed countries are 20% of the world's population, and they have low growth rates. So example, USA, Japan, Germany, France. There's less growth in those countries generally due to education a lot of times. People are working more. Developing countries, 80% of the world's population, they have high growth rate. Examples are Central America, South America, Asia, and Africa. And there's a question about where the carrying capacity for humans is and what that will look like. So far, we have a continued increase in population size in our world due to a lot of the factors are medicine, the fact that people are living longer, and those that have diseases are living longer than they would have in the past. And there's your overpopulated swimming area. That will end chapter 19. And populations.